Today we're going to talk about section 8.2, which is over arithmetic sequences. So in section 1 of chapter 8, we talked about what a sequence was and what a general term of a sequence looks like, how to find consecutive terms when given the general term expression, and we also talked about summation notation. Today we're going to expand on those things, but look at a specific type of sequence, and that is an arithmetic sequence. So by definition, an arithmetic sequence is a sequence that creates a pattern of addition or subtraction. That number that you are adding or subtracting to the term to get the next term is called our common difference. So you see it right here. Common difference is notated by a lowercase d. A lot of times in the problems we're going to do today, the d is going to be given to you. It's going to be shown. If it's not given to you, but you need it to be able to calculate other parts of these concepts, your d can always be found by taking two consecutive terms and they're subtracting them. So if I have, say, the pattern 10, 14, 18, so on and so forth, obviously for most of us, we are able to see that we are adding 4 to each term. But if we weren't able to figure that out, we would have to take any two consecutive terms, say terms 1 and 2, and we would take 14 and subtract 10 to get positive 4. Has to be consecutive, and you have to take the one behind it minus the one in front of it. That will always give you your d value. This formula is used to find consecutive terms. So in the last section, we were given a general term that we were able to plug in the number 1 to find the value of the first term. The number 2, 3, I could plug in the number 100 and I could find the value of the 100th term. When we're talking about an arithmetic sequence, this describes the definition. This says any term can be found by taking the previous term and adding or subtracting our d value. Okay, so that means if I'm looking for the 100th term, then I need to know the 99th term and I need to know d, because the 100th term is found by taking the 99th term and adding or subtracting our common difference to it. Now, this isn't something you have to memorize, but this does describe the difference. Any term in an arithmetic sequence can be found by taking the previous term and adding or subtracting our common difference. We're again going to be finding consecutive terms. In this case, they want the first 6. So we want a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. But they're not going to give us the general term expression anymore. They're not going to give us that polynomial that we plug the number 1, 2, 3 all the way through 6 into. They're going to give us the information that we need, knowing that an arithmetic sequence means we were adding or subtracting our d. So here they're telling us our first term is 100, so we won't have to calculate that term. Then they're saying any term in this sequence can be found by taking the previous term and subtracting 30. That means my common difference is negative 30. If my difference is negative, that means my sequence should be decreasing in value. So if my first term is 100, then my second term would be 100 minus 30, which is 70. If my second term is 70, then my third term will be found by taking the previous term of 70 and subtracting 30. So I'm doing, in this case, repeated subtraction because my difference is negative. If my third term is 40, then my fourth term will be 40 minus 30, which is 10. My fourth term is 10. My fifth term will be found by taking the fourth term of 10 and subtracting 30. Now I get negative 20. And my sixth term will be found by taking my fifth term of negative 20, subtracting 30, and I get negative 50. Okay. If my common difference is positive, you will add. You will do repeated addition. Here my common difference is negative, so I'm going to do repeated subtraction. Okay. In the previous section, when we wanted to find any term in the sequence, we had to have the general term expression, that 2n plus 7 expression that described the sequence. We would plug in that number of term and we would calculate it. They're not going to give us that anymore. When we know a sequence is arithmetic, We can find the general term expression or any term in the sequence by using this formula. We know that a sub n always represents an infinite sequence. Arithmetic sequences are still infinite. They will go on forever, but they are special because they will always create a pattern of addition or subtraction. So this formula says I can find the general term, a sub n. Remember, a sub n can be something like this. And then we can use that general term expression of 2n plus 6 to find any term. We would plug in 76 for n and calculate what the value is of the 76th term. Well, if we're looking for the nth term or the general term, then n's going to stay n. So n always represents the term you're looking for. So if you're looking for the nth term or the general term, n stays n. If you're looking for a specific term, n turns to that number of term you're looking for. A sub 1 always represents the value of the first term, so the value of term 1. And d, as we know, is our common difference, or a sub 2 minus a sub 1. Okay. We also have another formula that will allow us to find the sum. Again, in the previous lesson, we looked at summation notation and we also looked at how to find the sums. But because we didn't know what type of pattern it created, we had to find the value of the terms we were looking for to go into my sum individually and then add them up. If we know the sequence is arithmetic and our sum is starting at term 1, then we can use this formula. S sub n represents how many terms you're finding the sum of. So if I'm finding the sum of the first 50 terms, I would be looking for S sub 50. N is the number of terms in your sum. A sub 1 is the value of the first term. A sub n is the value of your last term. That is something you're always going to have to calculate. Okay, so let's look at some examples that will force us to use these formulas. Find the ninth term of an arithmetic sequence. Well, if we're looking for the ninth term, that means we're looking for a sub 9. Remember, a sub n represents a specific term. S sub n always represents the sum of some terms. So if we're looking for the ninth term of an arithmetic sequence, we know we're looking for a sub 9. They are telling us our first term is 6, so this is a sub 1, and they're telling us our common difference is -5. Well, if we're looking for an a value, a term, we're looking for a sub n equals a sub 1 plus n minus 1 times d. That is going to be our formula that will allow us to find the ninth term without actually having to do recurring addition of -5 to get to that ninth term value. So if a sub 9 is what I'm looking for, my a sub 1 term is given as 6. I'm looking for the ninth term, so n is 9. I'll subtract 1, and my common difference is -5. All I have to do is follow the order of operations over here in my formula. 9 minus 1 is 8. 8 is going to multiply by -5. So I get 6 plus -40 means that the ninth term of this sequence is -34. I could find this by taking 6 minus 5 and then term 2 minus 5, term 3 minus 5, and I could do that repeated addition of -5 or subtracting 5 over and over and over again. In my math lab, they will call that recursion, and they will tell you not to use recursion. They want you to use the formula. Another example, this one says write the formula for the general term. General term represents the nth term, which means we're looking for a sub n. What is that expression that is used to find the value of 2? What did I plug the number 1 into to get the value of 2? What did I plug in number 2 into to get the value of 7? This represents the first term, second term, third term, and fourth term. I'm looking for what is a sub n? What expression did I plug the number 1 into to get a sub 1 equals 2, a sub 2 equals 7, and so on and so forth? Then use that to find the 20th term. So eventually I'm going to use this expression to find a sub 20. If I'm looking for a sub n, and I know it's an arithmetic sequence, then I know I'm using this formula. Well, the first thing they want me to do is find a sub n. That means I'm looking for the nth term, so n is going to stay n. I need to know what is a sub 1 and what is d. Well, a sub 1 is given as 2. My d is not given, but we know d can be found by taking a sub 2 minus a sub 1. A sub 2 is 7, a sub 1 is 2, so my d value is 5. I'm not going to be able to solve this because I still have a variable in it, but I am able to evaluate it. 5 times n minus 1 gives me 2 plus 5n minus 5, which means the general term expression for the sequence 2, 7, 12, 17, and so on forever is 5n minus 3. This is the expression that can be used to find the value of any term in this specific sequence. What if I wanted to find it or use it for the 100th term? Well, then I would find a sub 100 and plug in 100 for n. In this example, they want me to use it to find the 20th term. So a sub 20, n is now 20, is 5 times 20 minus 3, means I have 100 minus 3. So the 20th term in this arithmetic sequence has a value of 97. Again, I could use this for any term in this sequence. I could use it for the 100th, the 127th, 827th, whatever you wanted it to be. Next example is we're going to do a story problem. Now, in real life, this is what you're going to use sequences for. No one's going to walk up to you on the street and say, hey, what is the 20th term in this sequence? 2, 7, 12, so on and so forth. But they will give you examples in your life, in your work. You're going to be able to figure this out, okay? Here's an example. Thanks to drive-thrus, Americans are eating more fast food meals than ever before. So a study was done in 2004, found that we as Americans average 32 drive-thru meals per year. Okay, that's an average. Some people eat more, a lot of people eat less. When that study was repeated, so every year that study has been redone, and it is found that we are, as Americans, increasing our intake of fast food meals by 0.7 meals per year. So that means in 2004, we ate 32 meals. If this was the first year the study was done, that means this is representing our first term, or a sub 1. So in the year 2005, if we added 0.7, that means our common difference is 0.7. So 32 plus 0.7 means that we are eating on average 32.7 meals per year. This would represent our second term, and we could continue to add 0.7, 0.7, 0.7 to get the value in each year after 2004. Okay? We want to take this information and we want to write the general formula for it. Give me that a sub n expression that I could use to find how many meals we're going to eat in any given year after 2004. Well, if I want the general formula, that means I want a sub n. We know it's arithmetic because we're adding a common amount of 0.7 per year. So we can use this formula to find our general term formula for this expression. If we're looking for the general term, n stays n, because we want to be able to change n then to any year. So the first year the study was done, we ate 32 meals. And when that study is repeated, we found that we averaged 0.7 more each consecutive year. So that's going to be 32 plus 0.7n when I distribute my d into n minus 1 minus 0.7. So in any given year, we can calculate how many meals we're going to eat by taking 0.7 times the term we're looking for, so what term represents our specific year, plus 31.3. Okay, now we could check that if I plug in the first year, which was representing 2004, 0.7 times 1 plus 31.3 does give us our 32 meals that the study showed. Okay. Now, if that general term can give us how many meals we're going to eat in any given year, let's use it to calculate how many we would eat in 2024. Okay, so 0.7n plus 31.3 is our general term expression for this sequence. Now, we have to figure out what term is representing 2024. Well, if a sub 1 represented 2004, that would mean a sub 2, or my second term, with 2005, and so on and so forth. If I continue with this pattern, a sub 3 would be 2006. Okay, so I count on my fingers. 2004, 5, 6, 7, 8, 9, 10, 11, 12, 13 gets me to 10. 14, 15, 16, 17, 18, 19, 20, 21, 22. 2023 would be 20. So 2024 is going to be our 21st term. That means n in this example has to be 24. We are trying to figure out how many meals will we eat in the 24th year of this study. Sorry, that's 21, excuse me. N is 21, not 24. Caught my mistake. N is 21. So we're looking for the 21st year this study was done. So we plug 21 in for our n value. 0.7 times 21 will give me 14.7 plus 31.3. So the 21st year of this study will show that we as Americans will eat 46 meals, drive-through meals, in the year 2024. Again, you could calculate this for any given situation. Now we're saying that 6n minus 4 is an arithmetic sequence. Again, arithmetic sequence means we're creating a pattern of addition or subtraction with our common difference of d. This is in summation notation, so remember, this formula can only be used if we are starting with our first term. Okay, so remember in summation notation, this on the bottom, the n is our index that tells us what variable will be in our general term expression right here. What that index is equal to is the term we're starting with. So the only time we can use this S sub n formula is when our index is equal to our lower limit of 1. We have to be starting with the term 1. Our upper limit here is 20. That means we're looking for the sum of the first 20 terms. 6n minus 4 is our general term expression. I'm telling you here that it is arithmetic. We don't need that. I don't have to tell you it's arithmetic, but we would need terms 1, 2, and 3 to be able to determine that there is a consistent pattern of addition or subtraction between at least 3 terms. But here I'm telling you it's arithmetic. I'm starting with the first term, so I know I can use this sum formula. Okay, this formula is where I always start. It tells me I need to know what n is. Well, I'm looking for the sum of 20 terms, so n is going to be 20. A sub 1, that is the value of the first term. Well, it's not given, but I know if I have the general term of 6n minus 4, if a sub n equals 6n minus 4, I know that I can plug in the number 1 for n to find the value of my first term. 6 times 1 is 6. 6 minus 4 means my first term has a value of 2. So in my formula, I have 2 of the 3 values needed so far. I know I'm finding the sum of 20 terms, so n is 20. My first term, a sub 1, equals 2. I need to find the value of my last term, a sub n. Well, if n is 20, that means I need to find the value of the 20th term, a sub 20. Okay, so 6 times 20 minus 4. 6 times 20 is 120. I'm subtracting 4. So my 20th term, in this case, has a value of 116. There's my last term. Okay, I calculated my first term to be 2. A sub 1 is 2. In this case, since n is 20, my last term is a sub 20. I calculated that to be 116. Now I can plug it into the formula, follow my order of operations, and get my sum. So the sum of the 20 terms of the sequence 6n minus 4 will be 20 divided by 2 times the sum of my first term, which I calculated to have a value of 2, In this case, a sub n is a sub 20, and I calculated that to be 116. 20 divided by 2 is 10, times 2 plus 116 is 118, means the sum of the first 20 terms has a value of 1,180. If we didn't have this formula, I would have to find the value of all 20 terms individually using the general term 6n minus 4 and then add them up. Nobody wants to spend the time doing that. However, in order to use this formula, you have to know what the notation represents, you have to be able to calculate the first term and the last term, and you have to be starting at the first term. If your sum is not starting at the first term, even if you know it's arithmetic, you cannot use this formula. Okay? If you have any questions, please let me know.